I'm pleased to introduce today's speakers, Karina Gallardo and Weishan Lee.
Okay, now I'm gonna state how we model the data and how we do the analysis. In this paper, the likelihood for each trait cluster is our dependent variable. So we want to measure how the selected factors influence the likelihood breeders will select for each trait cluster. So as Karina mentioned, the likelihood range from 0 to 100. So it is censored in both tail. Then in this case, we use double-bounded Tobit model to do the analysis. Here in this model, Y star is the latent variable. We cannot observe it. So if it's less than 0, the observed Y gonna be 0. If it's over 100, the observed Y gonna be 100. That's the censored part. So if it's in between 0 and 100, it's gonna be the observed value. The dependent variable is a linear function of explanatory variables. X is the vector of explanatory variables, include 7 parts. The first part is the rating for the supply chain considerations, influencing breeders' priorities. The second part is the ratings for challenges when determining priorities for selection. The third one is the years of experience of the breeder leading the program. The fourth one is the binary variable of the use of MBA at the breeding program is the 0 and 1. If they use MAB, it's gonna be 1. If the facility, if the breeder program they didn't use MAB, it's gonna be 0. The fifth one is the binary variable for region where the program is located. We have the location information. The sixth one is the binary variable for the use of targeted crop in the program, whether it's fresh or processed. The seventh one is the binary variable to indicate the main crop in the program. Here beta is the vector of parameters to be estimated, and epsilon is the error term. Here we have a list of variable names. So we use party 1, party 2 through party 10 to represent the ratings for supply chain considerations for different considerations. The challenges, we use DET challenge to represent the ratings for the challenges. Experience is the years of breeders' experience. MAB is the variable we represent whether the marker assisted breeding is used or not. Is the dummy variable 0 and 1. The regions include Pacific, California, Midwest, Northeast, Southeast, and Canada. The use of targeted crop, whether it's fresh or processed, we use this fresh to indicate it. It's an indicate variable. The main crop in the program, here we use apple, strawberry, peach, and red raspberry. And that's the main crops in the program. This is the short variable name. To make it clear, here we provide the variable details. So party 1, all the parties come from survey question 6. The description, the detailed description is here. So party 1 it represents the producer's needs. Party 2 represents wholesalers' needs. Party 3 is consumers' needs. Party 5 is the funding agency. Party 6 is the own experience. Party 8 represents the intended use of the crop. Party 9 here is the marketer's feedback. Party 10 is the retailer's feedback. Here we also have the detailed description of the different challenges. So for the challenges, challenge 1 is the lack of information on genetic material. Challenge 2 is the lack of genetic materials. Challenge 3 is the lack of information on method. In our analysis, we use the average of these 3 challenges as the lack of technologies. Challenge 4 is the poor communication with interested parties. Challenge 5 is the separate short-term from long-term needs. Challenge 6 is the difficult to find sensors across interested parties. Challenge 7 is the uncertainty if rarity being developed would be commercially viable. So all these challenges come from survey question number 10. Now let's go over the code we provided. The first part of the code are the comments. So the comments provide document information. Here in my comments, I mentioned which dataset do we use and what's the dependent variables, what's the independent variables, and the 2-bit model we use. And that's just to provide information to the, just to provide some information. Usually, people comment in SAS code very often. It's a good style to comment your programs. When you return to an old program you written months ago, and it may be difficult for you to figure out what you did and why you did it. So comments can help you to recall things. Also, if someone else need to look over your program, it's gonna be easier for them if the code is commented. So you can use the comment statement anywhere in SAS program as needed. You can use it anywhere. But when SAS when the SAS program executes, it will ignore the text in the comments. The syntax for comments is you can use star your comments and a semicolon, or you can use slash star your comments star slash. That's the syntax. Then this is the SAS code we used to import the dataset into SAS. So before you can use a SAS dataset, you have to tell SAS where to find the dataset. You do that by setting up a SAS library. So this first code is Libname. That's how we define a SAS permanent library. Libname, and this is the SAS library name. We name it data path and then give the path of this data set. Then in this case, we can tell SAS where to find our data set. Then the following is a data step. That's the statement how you can use this Libname to import your permanent data set into SAS. Then we use this data step to create our new variables. Let's go back. So this data set, when we use the permanent data set, we just set the lab name is data path dot trace. Trace is our data set name. So we set this data set into a new data set into the work library, work dot trace. The name is still trace. So in this data step, the main thing is that we created a new variable called lag, which is the average of challenge 1, challenge 2, and challenge 3. That's the data step. Then we use SAS macro variable name variable list to represent all the independent variables we have. We have so many variables, so we use this var list to represent all these variables. Then in later SAS code, we just use this var list to represent all these variables. When we use these variables several times, we do not need to rewrite all these variable names. We just use this var list to represent all these variable names. Then we provide proc means to get the summary of statistics. Usually it is good to see how the data looks like, what's the mean, what's the standard error, and some other simple statistics. So proc means can help us to do that. So in the var statement in the proc means that specify which variables to use in the analysis. The best statement performs separate analysis for each level of the variables in the list. Here, this proc means give us the summary of statistics of variable rank and likelihood for each cluster. This is the proc means output for cluster 1 and cluster 2. The variables are rank and likelihood. For cluster 1, there are 14 observations for variable rank and likelihood. The mean for rank is 4.8. The mean for likelihood is 89.85. So we also have standard deviation minimum and maximum value. So this is all part of the output. We have the proc mean output for the total 9 clusters. So here comes our Tobit model analysis. So we use Proc QLIM to do the analysis. Proc QLIM is a quantitative and limited dependent variable models. This QLIM procedure analysis limited dependent variable models. The Tobit model can be specified with censored option in endogenous statement. The bounds must be specified for the censored variables. Here in the endogenous variable is our likelihood. We have option censored to indicate that the model is Tobit model, and we specify the lower bound is 0 and upper bound is 100. So here is a part of the Proc QLIM output. First, the Proc QLIM give us the summary of fitness, and here is the parameter estimate. So this is all in part of the output for cluster 1. Actually, we did the Tobit model for each cluster. So we have total 9 regressions for each cluster, and the table shows all the results for these 9 clusters. You can also find this table in the paper. So the stars indicate that this coefficient is significant. If it's 1 star, that means the coefficient is significant at 10% significance level. If it's 2 star, that means it's significant at 5% significance level, and 3 star means it's significant at 1% significance level. So the sign of the output have meanings. If it's positive sign, that means this this variable positively influence the breeder's likelihood to select the traits. If it's negative, that means this variable is negatively influence the breeder's likelihood to select this trait. So the variable we have producers. So producers positively influence breeders' likelihood to select the texture. Wholesalers, marketers, and retailers. We also have other parties, other challenges, and all the output, all the results are here in this table. Okay, now comes to the conclusion and the implication part. Let's go back to Karina and let Karina to do the conclusion.